All right, so this is maybe the most meaningful of these videos. We're going to talk about class intervals, which are really useful for histograms, because in the last problem, we I have this information somewhere, had a bunch of data, and luckily the weights were all like they matched, and we could meaningfully have multiple of each. But in reality, right, if I ask 16 people their weights, none of them are going to be the same. Even if we round to the nearest pound, it's pretty unlikely that they're going to be the same. So our histogram would just be a bunch of ones for all the frequencies. So usually we bunch them together. How many people are between 100 and 110 pounds? 110, 120. Are we including the minimum or the maximum? Stuff like that. And that's what class intervals are all about. It's about filling these and clumping them into bins so that we have meaningful data that we can look at. Because usually it worked out last video, but usually these aren't going to fit into nice little boxes unless we shove them in the box. So that's what we're getting into here. So a lot of times they're also very useful for very large data sets where we're not going to list 500 things, right? We're going to just collect them into bins. And then usually these bins are 5 to 20. So classes, bins, however you want to think about them, chunks, it's all talking about the same thing. And they do have to be equal in size. It's a lot more meaningful if they do. So very frequently we'll do bins like this, especially when talking about like exam scores or something. Like basically this is like 120 to 130. That will count it as 129 and will include both endpoints. And then 130 to 139, assuming that all of our data is integer values, right? No fractions, because if there are fractions, then we could have 129.5 and that wouldn't fit into any bin, okay? And then make sure that these bins do cover everything in the set. So we'll usually use this formula right here, and we may have to round up, okay? So we're going to look at example 9.10, which is a nice, fun little example. If you're sad that you're at a community college, well, there are advantages and disadvantages to being at a community college. I'm not going to tell you that, oh yes, we're way better than other colleges in every way, right? But one of the ways that community college is awesome is a lot of community colleges do what we can to lower your costs in a bunch of different ways. Specifically, one of them is textbook costs. So the total cost of textbooks for the term was collected from 36 students. Hopefully not here. I know the math department's pretty good about this, but I'm pretty new, so I don't know if other departments have a lot of expensive textbooks. We're going to create a frequency table with 8 class intervals, and we'll include the relative frequencies. And we're going to make a histogram with these. So we're not going to count how many 140s, how many 160s, how many 165s. We're going to use class intervals. So notice it specifies exactly how many it wants. We need 8 class intervals. Okay. So we need to find the class range for each interval. We'll get into that. Okay. So luckily this is ordered in size, right? 140 is the smallest, 460 is the biggest. So we're going to use this formula. Class range is the largest value in the data set. That's $460, that poor student, minus the smallest value in the data set, $140, divided by the number of class intervals. And this problem told us we had to use 8. This cable is getting everywhere. And I'm going to sneeze, but not on the video. Okay, so we just use this calculation real quick and say, okay, what is 460 minus 140 divided by 8? And that is, in this case, exactly 40, but sometimes we'll round up. Okay, we may have to round this, but we don't have to here. This is our class range. So we're going to start with the lowest data and then make bins, right? These are the width of the bins or the classes. Sometimes they're called bins. I love the word bins. All right, so then we're gonna make our frequency table, right? Look back at the problem. Here's the data, create a frequency table with create a frequency table with relative frequencies. So that's our first step, and then we'll make a histogram. So our frequency table is going to be cost of textbooks. That's our data, the frequency, and it wanted us to include, my C turned into a Y, wants us to include the relative frequency too. So now, instead of the cost being counting up every single thing, 140, 160, etc., we're going to use the bins. So we're still going to start at 140, but now what we're going to do is go from 140 to 180, and we're not going to include the 180. So since these are all integer values, we're going to write 140 through 179. Now this is not super clear where this comes from. Look at it a different way. The first one starts at 140. The class range is 40. So the next one's going to be 180. The next one's going to start at 220. The next one's going to start at 260, right? We just keep adding 40. And then 300, and we just keep on adding 40 until we get to the biggest. 380, 420, 460. And now 180 goes all the way up to right before this. What's right before 220? 219, as long as we have integers, which we do. 259 is right before 260. 299 is right before 300. 339 is right before, and so on. Okay. And then this one would go up to 499. Although this last one's a little kind of weird. It's a little weird situation here. And then again, we were told to have 8 class intervals. So we should make sure we have 8. Now I'm getting a little nervous. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's what I thought. We were told that we wanted 8 class intervals. Okay, so what we're going to do is we're not going to have this last one. All right, the maximum data value is 460. So we're just going to include it in this last one. And this is very common. I just kind of got ahead of myself. 460 is the max, and we'll include that in the last one. So we want them to be all equal in size, but the way that it works out is that the last one's going to actually be 1 unit bigger. All right, so now we're just going to count for the frequency how many are in each range. So how many are between 140 and 179? 1, 2, 3, 4. Right? There are 4 that are in this first box. And then we keep on going. So maybe pause the video and do these on your own. It's not very useful if you just watch me and copy. So just get some practice tallying up all of these and then skip ahead and make sure that we are getting the same amounts. Okay? 180 to 220 should just be 1. 220 to 259. 1, 2, 3, 4. 260 up to 300. 1, 2, 3, 4, 5, 6. 300 to 340. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoa. 340 to 379. 1, 2, 3, 4, 5, 6. 380 to 419. 1, 2. And 420 plus. 1, 2, 3. And now we were told that there are 36 of these. So hopefully all of these frequencies should add up to 36. 5, 9, 15, 25, 31, 33, 36. Good. So the total is 36. That's important to check. And now relative frequencies are just dividing 4 by 36 and figure out what that is, and so on. So 4 divided by 36 is 11.1% approximately. And then we just go through all of these. 1 divided by 36 is going to be 2.78% approximately. This is still 11.11%. This is 1/6, which is 16.67%. 10 out of 36. Oh, it's just this times 10. 27.78%. This is still 16.67%. 2 out of 36. I just go through all these again. It's kind of boring. Make sure you're rounding correctly on these. And then 3 out of 36 is 1/12. There we go. Got our frequency table, got our relative frequencies. We haven't finished the problem yet, though, because it does want us to get a histogram as well. So the histogram is going to have these classes, these bins on the x-axis, and these frequencies on the y-axis. All right. So let's scroll down. Scroll down. It's a piece of paper, which I guess is where the word scroll came from, maybe. If you know this, you let me know. So for our histograms, we have a lot of classes. And then the biggest frequency is 10. So this is 10. This is 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe something like that. And then you'll just copy these bins down in here. Now you don't need to write 140 to 179. It's good if you do, if you have enough space for that. But what I'm going to do is just going to write, let's say, sometimes people do a little ziggy-zaggy here to show it doesn't connect. And we're just going to start at 140. And then let's say we're at 180, and then just keep adding 20, 220, right? That class range. Keep adding 40. This is 260. This is 300. 340. 380. I don't have room here. 420. And that's the last one. All right. And now 140 up to 179 is that first one. That is a frequency of 4. Make sure these all touch. 180 plus is a frequency of 1. 220 was a frequency of 4. 260 was a frequency of 6. It's kind of hard when I'm not directly over the paper. 300 was a frequency of 10. 340 was 6 again. 380 was 2. And 420 was 3. All right, so they don't need to be exact, just close enough. And again, you can use a computer for this. But if you're using a computer for this, be very careful that you have your class sizes correctly and the right number of class intervals. Make sure you're able to edit that. And ask me if you have any questions about how to do this, okay? Good luck, and we are going to do frequency polygons next, line graphs.